Hello, how are you doing? I hope you are keeping well, you are happy, you are safe, you are healthy, and also paying good attention to your studies. There is no alternative to classroom teaching, but we cannot help at the present moment, and this is the only way that we can study. As far as my memory goes, in the last lecture, we talked about nerve agents and nerve gases, and today we are going to discuss uh, another important war chemical. We shall discuss about phosgene. Phosgene is a choking or pulmonary toxin. We classified these war gases on the last term as vesicants and irritants. So, under that classification mechanism, phosgene falls under the pulmonary toxicant. Phosgene is a colorless liquid. It has got a what to call the very musty hay. Hay means भुस, जिसको भुस कहते हैं, मस्टी है जैसी स्मेल है इसके अंदर. और this chemical was synthesized by a Cornish chemist in 1812. 1812, this chemical was synthesized, and the chemical name of this phosgene is uh, carbonyl chloride, COCl2, or you can say that CClO, COCl2. So CClO, it is like this. CClO2, COCl2, carbonyl chloride. There are other synonyms, there are other names, but the common name by which we recognize phosgene is COCl2. If you remember, when we were talking about veterinary toxicology, we talked about a rodenticide, zinc phosphide. And I told you that when zinc phosphide goes to the intestine of the rodent, it produces a gas, and that gas is known as phosgene. It's the same phosgene. Phos means light, and genes means bearing. Cornish scientist John Day, his name was John Day. John Day synthesized this using carbon monoxide and chlorine, and he used a catalyst, activated charcoal. In the presence of activated charcoal, using it as a catalyst and using carbon monoxide and chlorine gas together, he produced another gas, organic compound, which we call as phosgene. And it is irritant, it is a pulmonary toxin, and it is a war chemical also. If you look to the applications, industrial applications, it's not like this that phosgene is not produced today. Phosgene is produced today, and it is used in the manufacture of urethane or polyurethane. It is used in the manufacture of other polycarbonate compounds. It is used for consumption as upholstery material. The cushions, the cushions that we use in bed, the cushions we use to sleep, and the mattresses that we use, all those mattresses are made up of a compound which is a polyurethane compound, and that polyurethane compound comes from it comes from phosgene, where it is used as an intermediate to produce these organic materials. People say that phosgene or this carbonyl chloride is also used in the synthesis of bisphenols. And these bisphenol A and B, like this, you must have heard about. They are established endocrinal disruptors. They are also toxic. It works like chloroform. If you take urethane, the pure urethane itself, and you take a fish and you put the fish into the dilute solution of urethane, the fish will be anesthetized I used to do it with urethane, and then you dilute urethane and put the living fish in the urethane solution, take it out, it will be paralyzed. You can manipulate the fish, you can dissect it, you can operate it, you can do whatever you want. In the same way, the urethane is also injected into rats. It is used as an anesthetic chemical. But the most important thing that we are going to discuss about phosgene is that it is used as a war chemical. United Nations Convention on War Chemicals has banned the use of phosgene now, but in World War One it was used, and also in 1938 the Imperial Japan, that was ruled by still ruled by a king, but it is just a monarchy. But at that time, the king was influential, Hirohito family. They used, they were fighting a war with China, and it is known as the Wuhan War. The same Wuhan that is such a popular name nowadays because of COVID-19. The same city had a war, and it is known in history as Wuhan War. And in Wuhan War, phosgene was used, and 85,000 people were killed by this gas. So the people got some alternative chemicals now. They have mustards, they have nerve agents. So nobody uses phosgene, but phosgene is used as was used as a war chemical in 1938 by Imperial Japan, and killed 85,000 people. Another accident took place in DuPont Company in America in 2011, where one person died due to accidental exposure to phosgene in some industrial activity. So this is to introduce what phosgene is. As far as the toxicity of phosgene is concerned, phosgene can affect skin, phosgene can affect eyes, lacrimation, tearing. Phosgene can affect the respiratory system, the lungs. It is very quickly absorbed by lungs, and there it leads to lung ailments. It leads to lung diseases like emphysema, like edema. These two are very important lung diseases, and phosgene is an etiological factor that if human exposure to phosgene occurs, it is very likely that lungs will develop edema and emphysema. Now, let us go further. And when we go further, we are to study that how it is metabolized. Lung, has got a detoxification system. Lung is a very important detoxification gland in the body. So when it enters through respiration into lungs, it is metabolized by cytochrome P450. Cytochrome P450 metabolizes it, and what are the metabolic products of phosgene? These metabolic products are hydrogen chloride. The metabolic products are reactive species. It leads to the formation of free radicals, and one of those free radicals is this hydrogen chloride. And hydrogen chloride, you see, the glutathione plays a very important role in detoxification of these radicals of hydrogen chloride, and they lead to the formation of mercapturic acids, and those mercapturic acids are ultimately excreted through kidney. So this is the major mechanism of biotransformation. How phosgene is biotransformed? It is biotransformed with the help of cytochrome P450. It leads to the formation of radicals like hydrogen chloride. Glutathione comes into picture, comes into play. Glutathione conjugates with these or scavenges these radicals and leads to the formation of the mercaptans, leads to the formation of mercapturic acid that I was discussing with your junior class yesterday. What is the toxicological significance of glutathione? The most important toxicological significance of glutathione is the formation of the mercapturic acid or mercaptans. So, with this background, if we move further, that how should we manage the exposure to to this war chemical phosgene. It can be managed with the help of a steroid, and that is the cortisone or corticosterone. It's secreted by the adrenal cortex, and the therapy is that if we find somebody exposed to phosgene, we are to first oxygenate or put him on ventilation. After oxygenation, after that stabilization, and when we come to know that this patient is a victim of phosgene, cortisone is administered. What can be the level of toxicity of phosgene? In human beings, it has been found that phosgene at the concentration of 0.1 ppm. 1 ppm means 1 milligram dissolved in 1000 milliliters of distilled water. It's 1.1 ppm. If phosgene exists even at this concentration of 0.1 ppm, it will cause toxicity in human beings. It's very dangerous. It's very lethal. Therefore, the Convention on War Chemicals has banned the use of phosgene. It is also used in the production of certain pesticides even today. The methyl isocyanate gas tragedy in Bhopal, that was also using some dangerous chemical like savine, and savine is very close to serine, soman, or taboon. So, but it was used as an intermediate to produce the methyl isocyanate, and then methyl isocyanate was again used to produce pesticide. So, similarly, the phosgene is also used in the synthesis or in the production of a few pesticides. In addition to these commercial uses of making the foamy material which is used in the upholstery that we use in our furniture, in our sofa sets, and etc. If we come to the animal toxicity, in animals it has been found to induce metabolic acidosis. We call it as metabolic acidosis, and it leads to respiratory damage, and the LD50 in animals is 1400 milligrams per square meter. In rats, 1400 milligrams per square meter is the LD50 for rats. In animals, only it can damage liver and kidney and lungs together. It can damage liver, it can damage kidney, it can cause skin irritation, and it can lead to respiratory damage. OSHA, Occupational Safety and Health Association, has put a biological exposure limit, and that limit is 0.1 ppm in human population. So these are some of the facts which are known for phosgene. It is generally in wars it has been used with chlorine, and chlorine produces some brown clouds over and yellow clouds, and it is mixed with the chlorine, or it can be used alone. There are chances that it can be used alone, or it can be used with the chlorine, and still the world production of phosgene comes out to be 2.74 million tons. According to a data which is available for 1989, the world production of phosgene amounts to 2.74 million tons. So that is how the phosgene is used. It smells like a musty hay, and it is used in the production of organic chemicals, right? And it can be dissolved in some other organic solvents. So this is in brief about a very important war chemical, phosgene. We have some other important war chemicals like the mustard gases and levisite. Maybe on some other time we shall be able to discuss on mustard gases. And there is another very important war chemical, Agent Orange. Agent Orange was used in Vietnam War, and mustard gases have been used widely in World War One and Two, and the Levisite was also used as a war chemical. So we shall be discussing briefly these chemicals, these war chemicals also. So uh, enjoy studying, stay home, keep safe, and we shall meet again. Bye.